recording for pre-calculus, and this is notes for section 4.2, part 2, and we're doing trigonometry, and this is looking at trigonometric functions on the unit circle. And so we talked about really developing that table of values and the quadrant chart that helps us give whether things are positive or negative, but I am going to use the unit circle for a few problems just to kind of give us the idea of how that is working as well. So to verify the points on the unit circle, note that that square root of 2 over 2, comma square root of 2 over 2 also lies on the line y equals x. So if you kind of substitute x in for y in the unit circle equation, x in for y, yes. And then you get x squared plus x squared equals 1, 2x squared equals 1, x squared equals 1/2, x equals plus or minus the square root of 2 over 2. So when that's in simple radical form. So just kind of a thought about that happening, and maybe looking at it just in another way, in thinking of it as still x squared, still x squared plus y squared equals 1, and using this point, then taking the square root of 2 over 2. Oh, I did not write that well. The square root of 2 over 2 squared plus the square root of 2 over 2 squared equals 1, and just validating that that is the case. So the square root of 2 squared is 2. 2 squared is 4. So you get 2 fourths plus 2 fourths. 2 fourths plus 2 fourths is 4 fourths, or 1. So we get 1 equals 1. And yes, it is true. And so just kind of think about that. And not only that, but apply that in your head to all these other ones. And it isn't going to matter whether those are positive or negative, because when you square them, the answer result will be positive. So it works at all of those points as we go. And also notice that this angle would be 45 degrees, which is, or pi over 4. And I'll just back up to our table, and at pi over 4 or 45 degrees, we see that sine and cosine are both the square root of 2 over 2. So lots of ways that we can connect this in our heads so that we have a better understanding of this as we go. And I don't even know why I have another picture of that, but maybe I'll want to use it as I go through things. Oh yeah, I think that's why. Let me just copy that in case I need it. And then this one has similar reasoning for things that are related to 30 degrees or pi over 6 or multiples of pi over 6. And this is the one where the slide maybe had a problem that wasn't, excuse me, a slide that wasn't correctly written in that original handout. So for this one, you know, let's just kind of pick one of these and just validate again. I'll just pick this one. And just kind of look at that. If I take negative square root of 3 over 2 and square that, plus negative 1/2 and square that, that's going to be negative squared is positive. We just talked about that. That'll be 3 over 4 plus 1 over 4, and that's 4 over 4, or 1. And so that one works as well. Also, just kind of thinking about what that little increment is in here. This is an increment of pi over 6. And so if we think about that, this would be pi, which is like 6 pi over 6, and then plus another pi over 6. So this would be 7 pi over 6, but that little reference angle, we're going to call it, is pi over 6. And then if you think about our table of values, and all students take calculus, tangent would be positive there. Sine and cosine are both negative. So the sine of 7 pi over 6 would be, and remember it's cosine, then sine is negative 1/2. And the cosine of 7 pi over 6 is that first one, which is negative square root of 3 over 2. And then if we kind of go back to that table again, then when we were at pi over 6, sine is 1/2, cosine is square root of 3 over 2, and when we're over here, only the tangent is positive as we go. Let me get rid of a bunch of stuff there. There we go. And so just some kind of reminders of those relationships as we go. And oh, it looks like I have some things showing there. Oh, I have my picture there already. Awesome. And so I am going to use this unit circle to do my work, although in practice I usually use the table and the quadrants kind of as we go. Oh, maybe that's why. Let me pause. Okay, so let's use that unit circle, and I'm sure you have some pictures of unit circles that you can use as well. And so these are in increments of pi over 6, and so let me just kind of slide that over a little bit. And so if we're on the unit circle, pi over 6, it's right here. And here is our coordinates of our ordered pair. We're at the square root of 3 over 2 comma 1/2. And if we remember, that's cosine t comma and sine t, alphabetical order. So just a little reminder of that. And we want all 6. Well, if we can get sine and cosine, we can get all 6 of these as we go. So we'll say sine of t is 1/2. Cosine of t is the square root of 3 over 2, and then tangent t is sine over cosine, so that is 1/2 over, let me slide my slide up a little, 1/2 over the square root of 3 over 2, and then we're going to invert and multiply 1/2 times 2 over the square root of 3. Notice those 2's cancel. We could also cancel them from back here and just say if they both have the same denominator, we can cancel those, but that's good practice as we go. And then that is 1 over the square root of 3. I have to rationalize my denominator, multiply by the square root of 3 over the square root of 3, and then I'm going to get the square root of 3 on top, square root of 9 on the bottom, which is just plain old 3. So there's sine, cosine, and tangent, and I usually write cotangent, secant, and cosecant kind of in a reverse order. Do not forget to put that t or theta or whatever it is we happen to be using, because it is the sine of the angle as we go. And now we'll just invert all of those. To be super honest, I want to invert the version that is right there instead of the rationalized final version, because then I just get the square root of 3 over 1, which is just the square root of 3. And so I will write it square root of 3 over 1, which is just the square root of 3. If I took the reciprocal of that final answer, I would have to rationalize the denominator again. So that saves me a little work. The secant is 1 over cosine, so it's 2 over the square root of 3 when we write that. And then again, we're going to rationalize, so square root of 3 over square root of 3. And then on the top, we're going to get 2 the square root of 3 over, and then square root of 9, which is plain old 3. So that one was a little more complicated. Sine, when we do the reciprocal of that, is the sine of t was 1/2, so the cosecant of t is 2 over 1, which is 2. And there's all 6 trig functions for that one. And using the unit circle, notice if we'd have used the table, and I'll just go back here, it was pi over 6. And so here's sine, cosine, and tangent, and then cotangent, oops, secant and cosecant are all those reciprocals. So here's our next one, and we're at 5 pi over 4 for this one. So the unit circle, this is pi, which is like 4 pi over 4. And so then we're at 5 pi over 4, so we go from the beginning there down to here. So there's our angle that we're using. This is our coordinates of the point on that unit circle. And so that is negative square root of 2 over 2, comma, negative square root of 2 over 2. And so those are, again, cosine and sine. So the sine of 5 pi over 4, and please always write what the angle is if you know it. And I guess I did not do that in the other one, or at least write it as t. So this is a better idea. And I should just label these as cosine t and sine t, just so we know which one we're using, although they are the same. So that's negative square root of 2 over 2. Cosine of 5 pi over 4 is negative square root of 2 over 2. Tangent of 5 pi over 4 is going to be that over that, and it's anything over itself is equal to 1. And then cotangent 5 pi over 4 is equal to 1. Secant of 5 pi over 4. I have to do that work. That's going to take 2 over negative square root of 2. And, think about it. Maybe you know what that's going to be. I'm going to multiply by square root of 2 over square root of 2. Notice I put my negative in the bottom, but in the end, I'm going to write it kind of out in the middle. And I have those on the top, but really you could write them out in the middle. You can see the book authors did a great job of that. I did not. And so that's going to be negative 2 the square root of 2 over plane 2. And that is negative square root of 2 when we cancel those little parts out there as well. Oops, I put my canceling. There we go. And those would become 1s then. And then if that's secant, then cosecant, oops, cosecant 5 pi over 4 is going to be also negative square root of 2, because once we have one, then the other one is the same. Why don't you go ahead and try this next one? And so we're going to get some undefined values. I'm just going to give you that as a little note, and see if you can use this unit circle approach to finding that. And then we'll kind of compare our results. Okay, let's compare and see how you did. I know my angle of pi is right there, and so that means my point negative 1, 0 is cosine t, sine t. So sine and cosine, tangent will be sine over cosine, which is 0. And then when I get in kind of some trouble. Cotangent is negative 1 over 0, so that's undefined. Secant, though, is just negative 1. Cosecant, also undefined. So hopefully you did well on that. And let's kind of move on. Maybe you want to try this one as well. I have this unit circle again. Remember that it's going in sixths. As you look at it, and it's negative pi over 3. So see if you can identify what that is. And I'll pause that again and let you try, and then we'll look at it. So for this one, negative pi over 3, we're starting here again, and let's see how we did. And so these are pi over 6, so pi over 3 is 2 pi over 6. So we're going to go down this far as we look at that unit circle. And so then our ordered pair that we're using is negative, or excuse me, 1/2 comma negative square root of 3 over 2. So how did you do on that? And then let's see the rest of this. So we'll say that those are cosine and sine. And so the sine of negative pi over 3 is negative square root of 3 over 2. Cosine is 1/2. Tangent, I get negative square root of 3. Cotangent, when I use the reciprocal there, hopefully you're kind of cluing into the fact that, oh, negative 1 over the square root of 3 is going to be negative square root of 3 over 3. And then secant, we just flip that 1/2 to make it 2. Cosecant, we get negative 2 over the square root of 3. Rationalize the denominator, negative 2 the square root of 3 over 3. And then I did go back and I thought, you know, I should have put parentheses around each of those as I did it to have a little better form as we look at that. So now we're going to move on. The next subheading is domain and period of sine and cosine. And so now is when we get to think of that unit circle as a Ferris wheel. It's always one of my favorites. And, you know, even the Mall of America, I don't even know, you know, who has even been there because of the whole pandemic. But they have that big Ferris wheel, and it's as close as I've ever seen because it is not, it does not have a diameter where you get on, but, you know, it is raised off the ground, and you're on that maybe second level, if I remember right, and you go around that merry-go-round, or yeah, Ferris wheel. Ferris wheel, not a merry-go-round. Well, a merry-go-round could be the same thing if you thought of it horizontally. Okay, anyway, going ahead. So the domain is the set of all real numbers for sine and cosine. You want to be aware of that. And to determine the range, look at kind of and think about these x and y values. Notice that as we go around the unit circle, um, the x values, which are cosine, go from -1 to 1, and so do the y values. They go from -1 to 1, but in different places, so to speak, as we look at that. And so let's kind of think about what that means then. And we're just going to move on to the next slide, maybe. There we go. By definition, the sine of t, or sine of t, is equal to y. The cosine of t is equal to x. So, you know, we know this is cosine t comma sine t for our ordered pair, and it's a unit circle, so we know that they oscillate between -1 and 1, and either one of them does that. And so that is going to help us get our ranges, and they indeed do go from -1 to 1. Even if we repetitively go around that unit circle, and so we have angles that are greater than 2 pi or less than -2 pi, I guess is how I would say that, we still find ourselves in a situation where that's always going to be oscillating between 0 or -1 and +1 as we go. And then just thinking about that adding of 2 pi, and maybe just kind of looking at one of these as we go, think about the fact that maybe if I start here and I have my initial side right there and I spin a whole time and then another one, well, the smallest angle there is pi over 4, and then the next one is pi over 4 plus 2 pi, and then the one after that would be pi over 4 plus 4 pi, and then pi over 4 plus 6 pi. And so in general, we can say that t is pi over 4 plus 2 pi n. So 2 pi for every unit circle, and then n is an integer. Because remember, we can go in that negative direction as well. So if we go this way, it's like 2 pi minus pi, or -2 pi plus pi over 4 is really how I would say that as we go. So the critical learning of that little piece is this, that the sign, oops, of t plus 2 pi n is equal to the sine of t. And likewise, the cosine of t plus 2 pi n is equal to the cosine of t. And because of that, we get that cyclical behavior. Ooh, cyclical behavior. I like that. And these functions, since the functions that behave in such a repetitive or cyclic manner are called periodic. So these are periodic functions, and that's what we're going to do is write some good notes on this next slide. So the definition of a periodic function is that a function f is periodic when there exists a positive real number c, and in this case it's 2 pi, such that f of t plus c equals f of t. And for all t in the domain of f, the smallest number c for which f is periodic is called the period of f. So, and this does change with different trig functions. Maybe you've had some experience with that. So the period of the sine function of sine function is 2 pi, and the period of the cosine function is also 2 pi. And then maybe kind of think about in your past, you've maybe drawn these at periods, and we'll just kind of put it in there. And the period goes to 2 pi, so this is pi, and this is 2 pi, pi and 2 pi. And they oscillate from -1 to 1 and from -1 to 1. And so for sine, it starts at 0, and then it goes up to 1, and then back to 0, and then down to 1, and then back to 0. And there's our sine function. Cosine starts at 1, goes to 0, -1, back to 0, and then +1. And it looks like that. And that's all of the nature of going around that little Ferris wheel and that cycling behavior as we go through. And sine and cosine both have a basic period of 2 pi, and you want to know that for sure. And so this is the definition of a periodic function. You can write what you want there. And then remember even and odd function. F is even when f of t, or f of negative t equals f of t positive t, and it's odd when f of negative t equals negative f of t. And so then we can see what trig functions are even or odd. And even and odd trigonometric functions. So cosine and secant are even. And that means when you put in a negative, you get the same as the positive. And sine, cosecant, tangent, and cotangent are all odd. And that means when you put in a negative, and I'm not going to underline every one of those. You're just going to maybe write all those down. When you put in a negative, sine of negative t, you get the negative sine of t, or that opposite value as you go. Pause this if you need to write some things down, and then we'll move along. Now, we want to use this periodic nature of the sine and cosine functions to kind of evaluate these. And that's going to help us down the road so that we don't have to like draw a unit circle all the time, and also using that table of values. So think about the fact that we have this unit circle. If we, every 2 pi that we spin, gets us kind of back to the same thing. So we want to kind of rewrite this any angle in terms of 2 pi plus or minus some small, generally positive angle. It wouldn't have to be. We could use the negative as well. So this is the sine of 13 pi over 6. And I will just tell you, FYI, when you're thinking about that unit circle, if the denominator is 6, kind of keep in mind this is 0, this is 3 pi over 6 because it's a half. This is 6 pi over 6. This is 9 pi over 6. And this is 12 pi over 6. So, we don't really count that way, but you want to have that in your head, because then when you look over here from that over to this 13 pi over 6, then it's easy to say, oh, look, 2 pi is 12 pi over 6, so this is 13 pi over 6. What does that mean? And what that means is this is the sine of 12 pi over 6 plus pi over 6. We'll leave it as 6, but then we'll say, oh, that's the sine of 2 pi plus pi over 6. And then if we can say it's 2 pi plus something, or even a multiple of 2 pi, we can say that's sine of pi over 6. And then hopefully we know that the sine of pi over 6 is 1/2. And I'm going to defer myself to that table of values now, and let's see what we've got. So 30 or 0, 30, 45, 60, and 90 are right there, and pi over 6 is 30 degrees, sine, cosine, 0, 1/2, square root of 3 over 2, and I need the sine, so that is 1/2. And it's in that first quadrant, because think about what that meant. We went 2 pi and then another pi over 6. So our angle that we're talking about is right there at pi over 6. We're going to call that a reference angle as we move on. Now, if you want to, go ahead and try this one, negative 7 pi over 2. And notice it is negative. And then pause this and then see what happens. Okay, let's see how you did. Well, first I'm going to kind of use my pi over 2 idea. And it's going backwards, so I'm going to say this is, 0 there. And negative pi over 2, negative pi. Which is negative 2 pi over 2, and then negative 3 pi over 2, and negative 4 pi over 2, and negative 5 pi over 2, and negative 6 pi over 2, and then negative 7 pi over 2. And so then look at where I ended up. If I kind of draw that out as a picture, I end up right there, which is the same as positive pi over 2. And when I have one like this, I'm generally going to think about these points that I could put on here. And this point would be 1, 0. This one is negative 1, 0. This is 0, negative 1. And then the one I want is 0, 1. And that's cosine t comma sine t. So formally, I'm going to say, okay, the cosine of negative 7 pi over 2 is the same as the cosine of, well, let's think about that as in terms of 2 pi's. So if I would have kept going around here, negative 7, there's negative 8 pi over 2. And then I'm going to kind of add a pi over 2 to get negative 7 pi over 2. So I'm going to say that is actually like having negative 8 pi over 2 plus pi over 2, because that's the cosine then of negative 4 pi plus pi over 2. And 4 pi is just 2 revolutions. Doesn't matter that they're negative. So that's going to be equal to the cosine of pi over 2. And then the cosine of pi over 2 is equal to 0. As we look at that. And we're just kind of stretching ourselves a little bit, looking at that as a unit circle. Certainly you can use that table of values and those quadrants as you go as well, and those quadrant angles. Now, 2C is a different kind of problem. This says evaluate sine of negative t given that sine of t equals 4/5. So notice here we do not know what the angle is, but we do know that the sine is 4/5. Positive 4/5. And so let's kind of think about that as we go. So we know that sine is odd because this is negative t and this is positive t. So sine is odd, and that means f of negative t is equal to negative f of t. So at first it might seem like we didn't have enough information, but here that means that the sine of negative t is equal to the negative sine of t. So the sine of negative t, which is what we want, is negative. Well, in place of sine t, we're going to put 4/5. And maybe I'll even like write that in parentheses, 4/5. So we just get negative 4/5. And that is all we needed to do in that one. Now, moving along, when we're evaluating a trig function with a calculator, we need to set our mode in either degrees or radians. So the little calculator that you're using, I do not have one for on the screen yet, although I think we've ordered them. And a lot of calculators don't have cosecant, secant. They do have degrees or radians, so make sure you set the mode. And they don't have cosecant, secant, and cotangent. So you have to use either the x to the -1 or 1 over sine, cosine, whatever the case may be. So I think I have a slide just that kind of walks you through that. Go ahead and just make sure that your calculator is in radians and just attempt that problem. And you can do it that way, parentheses, sine, parentheses, pi divided by 8, parentheses, parentheses, then pushing that x to the -1. That's one way. And you could also try just letting you know to type that in as 1 divided by, because since it's 1 over the sine, you could go 1 over divided by sine, parentheses, negative, or pi over 8, and then enter. So actually, I would strongly suggest you just trying both of those on your calculator just to see that you can actually use them as you go. Then moving on, go ahead and take a moment and try these two problems, 3A and 3B, and see what you get. And then moving on, we'll check our work. Here's what you should have gotten, and as you go through that, and then that concludes this section, and you should be able to identify a unit circle and describe its relationship to real numbers, evaluate trigonometric functions using the unit circle, use domain and period to evaluate sine and cosine functions, and use a calculator to evaluate trigonometric functions. So this concludes 4.2, trigonometric functions using the unit circle. Have an awesome day.